Okay, Venn diagram. Venn diagram is a pictorial. Is a pictorial representations. Representation of a set in which sets are represented by enclosed areas in the plane. So you know the Venn diagrams also, and if there is the universal 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 set U universal set U is represented by interior of a rectangle. Okay, let's say we have three sets as an example. We have three sets like A as 1 and 2, like our previous example, and B as 4, 5, and 6, and there is a C, 5, 6, 7, and 8. Okay. Show representation of sets using Venn diagrams. So we have as a universal set is a rectangular form like that. Okay, this is the solution or answer of the example. Okay, let's say we have a set like that, and there is the 1 and 2. 1 and 2. Okay, I don't remember we have to put as a dot or not. Okay, 1 and 2. This is the set of A, and 4, 5, and 6. 4, 5, and 6. This is the set B, and there is the 5, 6, 7, and 8 in set of C. So this is the representation of as a universal set. This is the representation of universal set. Okay. You can hear my voice and you can see the shared page, right? Okay, yes. Chris said yes, Anil said yes, Furkan said yes. Okay, we represent like the disjoint A and B. There is not disjoint B and C as a universal inside of the universal set, like U, V. Now is okay. Screen is hidden. Now is okay or not? No. Okay, when I open the chat page, you can see. How about now? Now is okay. If I do like that, okay, it is working. No, it is okay. Now is okay, right? Yes, yes. Okay, thank you. Okay, there is the, arguments and Venn diagrams. There is the arguments and Venn diagrams. I will jump here also. You can read it. Arguments and Venn diagrams. We don't need so much details like that. But you can read it. Okay, read. There is the example. Example 1.3, giving some, detail, and read also here. This is again your homework. Okay, new title is a set operations. Now is the set operations. We are on page 4. Page 4. Okay, there is the set operation as a union and intersection. Union and intersection. The union, okay, definition of the union of two sets A and B, A and B, denoted, there's the symbol of union by A, like the U symbol B, A is the union, A and B, a union is the set of all elements which belong to A or to B. So we can write A union B is like there is the X element of A and B. We will write X is the member of set A or belong to A, or X is the member of B or inside of the set B. This is the union. The intersection for union and intersection also like the or and operator. When you look the different approximation, you see this is the union like the or operator. And let's write the intersection. The intersection of two sets intersection of two sets A and B, two sets A and B, denoted by A symbol like the reverse side, upside down U, B, which is the intersect A and B, is the set of elements which belong to both A and B. So this is the A intersect B. There is the X as an element. X is element of A, and now is the end operator. X is the element of B. This is the intersect explanation. Okay, we saw union and intersection. Okay, let's continue. The page 5. Okay, page 5. Completed my all empty page. I'm going to use that notebook and new title is page 5. Also, we can represent we can show relation. We said relation.
Ağzına bir şey yaptık mı?
Operation. We can show sets operation using Venn diagram. So it is like there is the union set, the first one, unions. I'm sorry, universal set. I'm sorry. And here is the case 2. Again, universal set. Okay, A and B This is A, B, universal set. And here is again A and B. In universal set. So first one is a union B. I will shade A union B in that universal set like here, right? Is a union. If A intersects if A intersects B, if you want to shade, we will say that part, right? Okay. Here is the explanation again. Recall that sets A and B are said to be disjoint or non-intersecting. If they have no elements in common or using definition of intersection. If A intersects B is equal empty and S is a set as A union B and there's the A intersect B is equal empty. So example, there is the example talk about the union and intersect. We can do easily ensure. Example, let's say there is the set of A. This is again from your book, and inside of A there is 1, 2, 3, and 4. Those are the elements, and there's the B set, and inside of the B 3, 4, 5, 6, and 7. And there's C, the set inside of the C there is the 2, 3, 8, 9. Okay, let's write. Let's find the case A union B. Case A. So what is the first one? What should I write? Is it 1, 2, 3, 4? 3, 4 are common. And 5, 6, and 7 is gonna be members of A union B. 5, 6, 7. So this is the A union B. So I do not write, 2 times 3 and 4. I just write 1 times. And okay, A intersect B. So what is the common element for A and B? What is the common element A? Do you hear my voice? Yes. Okay, 3 and 4, yes. You can hear my voice, and 3 and 4 intersect A and B. Okay, A union, okay, A union, that's right here. A union C, A union C, that's right. 1, 2, 3, and 4. 1, 2, 3, and 4 as a union. There's 3 already written here. I'm sorry, 2 and 3 are already written here, and 4, 8, and 9. 8 and 9. Okay, intersect A, intersect C. B intersects C. So, what are those as a common? 2 and 3. Yes, 2 and 3. And B union C. So, what are the union? 2. There is no 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then B intersects C. So what is the B intersect C? There is 3, okay, this is the common. Let's find 3 here. And what else? There is no 4, there is no 5, there is no 6, and so on, just 3. Okay. So this is enough. You can say A case, B case, and C case. There's a question has as a case B as a written like there's some explanation, but to get the idea is enough. Okay, let's move. Let's do a solution. And there is some property from your book, property 1 and property 2. You should know those. Okay, let's write that properties. Property 1. This is the page 5. Page 5. And property 1. Can we write that? Okay, we can write this is the directive. We don't need any explanation. A intersects B. If there is the intersection, we can say this is a subset of A, of course, right? And we can write also there is A intersect B. This is also again subset of B. So property 2, A is subset A union B. This is clear, right? And B also subset is contained by A union B. Okay, let's try the theorem. The theorem 1.3. So these are the clear, right? Simple and clear. The theorem 1.3 for any sets A and B, we have the first A intersects B is a subset of A. So this is a subset of A union B. There is also, from the dot properties, we can write the secondly A intersects B. Okay, this is the A. So A intersects B is a subset of B, subset of B. This is also subset of will be covered by A union B. This is theorem 1.3. 1.4. 1.4. Okay, let's run 1.4 here. I hope we have enough space. 1.4. The following are equivalent. A is contained by B. A and B. A intersect B. If A intersect B, you have to be, point that equality is equal A. You see, A intersects B is equal A. A union B is equal B. So this is also clear, right? If A is subset of B, it means A intersect B will be exactly is equal to A. A union B is going to be is equal as a B. So this is the theorem 1.4. Any question? And I said yes, clear. Okay, thank you. Okay, next page is a page 6. Let's jump that page. Page 6. 5 and 6. So we cover so much beautiful part of chapter 1 and new definition for that chapter. As a complements differences, symmetric differences, as a, again set theory and complements differences and symmetric differences. This is the new title. We call that all sets under consideration at a particular time are subsets of a fixed universal set U set U, the absolute complement, the absolute complement or supply complement of a set. Set A denoted by A upside, letter A upside like small c. This is the complement of A representation, is the set of elements which belong to U but which do not belong to A. So this is the complement. So we can say as a form of complement A, there is the X. X is the member of or element of set U, but not member of set element of A. So if you want to show that one as a Venn diagram, okay, let's say there is a universal set, and inside of that set is a set A, and here is the universal set. So if you are looking for the A complement, is a shaded A complement outside of set A. If there is any set or if there is any element, you will say this is the complement side of the set A. A relative complement of a set okay, the relative complement of a set B with respect to a set A, set A, or simplify the difference. So the relative complement and simplify the difference of A and B denoted by A difference B. A difference B, like that, is the set of elements which belong to A but which do not belong to B, but which do not belong to B. So there is also, explanation relative complement or difference A difference B. So we will represent like that, and it is the shown like there is the X. X is the element of A, but X is not element of B. Also, you can say the set A difference B is read like A minus B, or there's some different notation or representation for A difference B. You can see sometimes like A minus B, but in that book, you will use that one, A difference B, in that form. Okay, there's a symmetric difference. There's a last one in that title. The symmetric difference of sets A and B denoted, we will use as a denoted by that symbol A symmetric difference B. It is the plus inside of the circle consists 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 of those elements which belong to A or B but not to both. So for symmetric difference A and B, we can write A union B minus the difference A intersect B. This is a symmetric difference. We can show in we missed that one as a minus B. I'm gonna use here A minus B, the Venn diagram. A minus B. So here is the A and here is the B. A minus B will be that side. But you won't shed any, intersect A, B. is shaded. And for symmetric difference, let's say we have universal set A and B. A, B, U. Symmetric difference will be shown like here. If you say this is the shaded of A, symmetric difference B is shaded. There is also, dear friend, there is also one more form of A difference and symmetric difference B. If you A difference B, A minus B union B minus A or B difference A also is equal to symmetric difference of A and B. So we covered page 6 also, and we continue fundamental product. Okay, let's write the fundamental product, then we will complete this week's lecture. We have time, I think, right? Do we have time, Emre? Yes, 15 minutes. Okay, 15 minutes without break. This is page 57. Okay, now is the fundamental product. This is also important definition, fundamental product. So what it means, let's see, fundamental products. Consider, okay, let's say there is the n distinct sets. There is the n distinct set like A1, A1, A2, and A3, and so on. There is the AN, a fundamental product of the sets is a set of the form A1 star, A1 hat star intersect A2 hat star and intersect A3 and so on to AN star. So AI star is equal A, or AI star is equal A complement. And then there is some case like 1 there are m is equal to power n such fundamental products and second, any two such fundamental products are disjoint and third one, the universal set U is the union of all fundamental products. That's okay. Let's use the example to explain fundamental product. Example, we have 1.58 example. We have, there's no problem. Okay, we have then let's say Venn diagram of three sets A, B, C. Define or write my fundamental product of these sets. Either the set A and B and C. This is the set A, B, and C. This is the universal set. Okay, this is the question. Okay, fundamental product of A is a solution. The first way to write in universal form, like that. There is the A again, B, this is gonna be really hard, and C. I'm sorry for my drawing ability, C, U. Okay, let's say it's really hard. Make it bigger, show here. Bigger A, B, and C. So rectangle. U, A, B, and C. So there's the, as a product P1, P2 here. P1, P2 is covering that area as a P2. And P3 is here, P3, P4, 5, 6, no, that is here. So you can change it, but 5, I'm going to use 5 is here, 6 is here, and 7 is here. Okay, product P1 as a second P1 is equal A intersects B intersects C. So fundamental product of ABC is a P1 and P2 is A intersect E intersect complement of C. P3 is equal A intersect B complement intersect C, and P4 A intersect B complement intersect C complement. P5 A complement intersect B intersect C, and P6 A complement intersect B intersect C complement, and 7 A complement B intersect B complement intersect C, and last one is a P8 AB product P8 is here. Product of 8 is equal all complement of A complement intersect B complement intersect C complement. So did you get the meaning of complement? We have last 6 minutes. Do you think that we continue? Okay, we will start on our next lecture, the 1.5. I will do, fast lecture because I'm going to try cover, all thing for that term. Okay, 1.5. Okay, next. And title Algebra of Sets and Duality. This is the next title. Please remind me, we will start with that title. I will send you for all lecture notes. We totally completed 7 page. And also we already passed the, I think, half of the chapter 1. And next week I'm planning to finish chapter 1 next week. I'm planning to finish chapter 1. Then I will start the relations as a chapter 2, because relation is really important. Functions and algorithms is also really important. Our main goal to come, quant counting in graph theory, counting techniques and graph theory are our main part. Any question? I'm going to finish the lecture. Do you have any question? No. But Batuhan writing as a no. Cat said what? We have 22 students. Okay, Peter said no. One said clear. Okay, thank you, dear friend. See you next week in the new part of our chapter 1. Thank you for all. See you next week.